Hi, everyone. My name is Michelle Lee, and I'm the director of the Master of Business Analytics program. I'm joined today with Associate Professor Swati Gupta, who will talk about her background and her journey here at MIT. Welcome, Swati. Would you like to introduce yourself?
Thank you, Michelle. It's my pleasure to be here and to talk to all of you. My background is in computer science and mathematics, and I'm a professor of operations research and statistics at Sloan School of Management. And I did my undergrad at IIT Delhi in India. I majored in computer science, but I always had this tension of, I loved math and then I wanted to do CS. So I was a CS major, but I took all math courses.
Oh.
And then when I came for a PhD to the US, I found my place in operations research, which is like the right combination of theory and algorithms and actually making an impact in practice. So a lot of my work these days is on machine learning and optimization and AI, all the cool stuff. But we also look at various applications where we can have a direct impact on lives of people. We can help society. We care about making ethical and algorithmically fair decisions. And we think about all of this in the changing landscape of various laws and policies and how they interact with the algorithms that we have in the world around us today.
Very cool. Can you tell us a little bit about your most recent research and what your research concluded?
Recently, I've been very curious about a lot of topics, ranging from how do we allocate organs ethically. Some of these new technologies have to do with cryopreservation and xenografted organs. So we've been thinking about, how do we assess which patients need organs the most? What is going to be the benefit of these new technologies? And how can we actually develop that supply chain logistics system around the space to quickly get the organs before their quality deteriorates.
Wow.
I've also been thinking about how do we make admissions and hiring processes more easier. Right? Like throughout my life, I was trained to look at numbers and take them at face value. But what I've learned in the last few years is that numbers only reflect an approximate quantity that we've been able to measure. And there's a lot of noise in our measurement of individuals. So there's not a number that I can put on everybody and say that this person ranks above this other person. So some of my work recently has been also on understanding how do we design hiring algorithms that give people the benefit of the doubt, that allow interview committees to select people that show the promise, perhaps that we don't have exact measurements on all of them, but we don't penalize them for not having those exact measurements. And the same kind of thinking goes into admissions processes as well, where students who, let's say, have they have better financial resources, they can take exams like the SATs and the GREs again, and they can improve the scores and they can report the top performance. However, what about students who don't have the means to take these exams over and over again? And we have a noisier estimate on the quality of these students. So my research has been around, how do we still account for that noise in a way that's fair to everybody, that gives people the benefit of the doubt. But ultimately, all of these problems are about allocating a limited amount of resources to a diverse population.
Wow.
And we see these ideas also go into generative AI and LLMs and some of the new AI advances that we're seeing these days. When an LLM trains on certain objectives, or it's trying to find policies, or it's trying to find types of solutions that, let's say a call center should call this cohort of people to have the maximum impact, a human decision maker can then go back and tell the LLM that, no, I want to have more diversity in the number of people I call. And perhaps, I want to make sure that we call, let's say, expectant mothers who would really benefit from certain information during their pregnancy. But another human decision maker could come and say, well, I really care about giving that information to uneducated people because they would really benefit from such information. And so again, we are in this space of having constrained resources. We have a small number of callers in a call center that might call a diverse set of expectant mothers. And the question again is, who should we prioritize based on the need and the benefit that they will have from these limited resources?
Wow, that's amazing. You're doing so much. It's from call centers to admissions to organ donations. What if a student out there in the audience would like to work with you on your research? How do you go about finding students to do research with?
My metric for finding students, and I've worked with a lot of students from very diverse backgrounds, is the first thing I'm looking for is passion for the research. So if you're passionate about something and you're passionate about a problem or you're passionate about a theoretical question, then that passion basically allows you and makes that space for you to grow in that area, to think creatively about new solutions and to really learn. And then after passion, I think from a very practical perspective, to immediately make impact on research, I look for course preparation. So I look for strong mathematical preparation in courses, because in today's world, to make these algorithms scale and be robust and reliable, we need to develop mathematical guarantees. So we cannot have heuristics where we don't know how they're going to perform on unseen data, but we want to be able to have robustness or reliability guarantees. And for that, I look for students who have some friendship with mathematics, who have taken some logic courses or proof courses, some people who can even prototype things very fast. So they can test their ideas, they can code up things fast. And that's what the MBAn program also equips them to do. So I actually work with a lot of MBAn students, and these students have come from either they have more of a machine learning experience, they have some background with data analytics, so they can bring that into the projects and they can work with the data, they can estimate uncertainties and biases, they can develop algorithms and they can implement and see the impact. Some students that I work with are really come from like this mathematical perspective where they're able to look at the mathematical model and prove guarantees about it. And so I've had a lot of fun working with students across these trends and see them contribute to projects.
Wonderful. And I know you're also an advisor for Capstone projects. Can you tell us a little bit about the Capstone projects that you're working with or have worked with in the past?
So Capstone project experience was a fantastic experience that I was basically exposed to at MIT. And I really enjoyed working with Capstone companies in the last couple of years. So I've worked with Accenture, I've worked with Cognera and Comcast. And Accenture started with a very open-ended project, which I thought was a big challenge for the students. So it was not something that was very precisely defined. The project was about quantifying the impact of generative AI and how aggressive companies need to be in their investment in generative AI to have a competitive edge over their competitors. And I thought this was, generative AI being a new AI advancement, we were kind of in the space that we don't have any benchmark. How do we kind of say that this is going to be the impact of this new set of tools, right? I thought this was a very open-ended project, but what we could ultimately develop from that was assess using a very involved Markov decision process. The students developed a tool where any company could put in their parameters and then see what is the growth of the company in the next 5 years or 10 years in a planning horizon. And they could compare with the market and see, how aggressive the generative AI investment needs to be. I thought that was a very cool project. My other project was with Cognera, and Cognera is a retail and analytics company. And they've gone from kind of the space of understanding pricing strategies, and they go all the way to supply chain management. And so this project was about estimating impact of promotions of different kinds on the sales of different products. So if you promote, let's say, pasta and pasta sauce together, then the sales of both of these products will go up. If you promote Coke products, then maybe Pepsi product sales go down. And so one promotion leads to a loss of sales in the other product. And so these are cannibalization effects. And this is a very challenging mathematical question that when you have signals that are mixed because of promotions in one quantity, you have mixed signals in the others in terms of their baseline sales. How do you estimate that impact? And so our team of students and the team from Cognera, we all put our brains together and we came up with this very interesting market normalization baseline above which we could kind of estimate these impacts with a higher fidelity. And there were discussions about, converting that into a patent or something that the company could really convert into its bottom line. And I thought that was very cool because, students went from defining the project, getting the data, implementing something, and showing something that was not done before in a very short span of time.
Yeah. Our projects last only about 6 to 7 months.
Right.
So they have to work really
very
fast.
quickly ramp up and provide results. And so these students also got, if I'm not mistaken, pre-placement offers from these firms.
Yes, that is the goal.
Yeah.
So, great. Well, thank you so much for your time today.
It was my pleasure.
We look forward to seeing what you'll do next.
Thank you.
And we'll see everyone very soon. Hi, everyone. Thank you for watching. If you like this video, check out our other videos in the series where I interview influential professors at MIT Sloan. If you would like to learn more about the Master Business Analytics program, we also have a playlist where you can see more videos about the admissions process, student life, and the program overall.